Hello everyone, in this tutorial we will create AI vehicle that can move to any target location. When we click on this location, and then the vehicle will do the speed trace in grid form and calculate the path to that location. We will create another mode is the vehicle can follow the player vehicle. Go to Window and open this world setting. Now we use game mode, override game mode, and this default pound is default pound. When we play, we can navigate around this, but we can't choose the target location. So we need to create another pound to behave the same as this default pound. Blueprint class. Create a new game mode. Name is vehicle game mode. Open this. We will change this default pound class. Create a new blueprint pound. Name this to BP Spline pound. And we can go to this game mode. Choose BP Spline pound as this default pound class. When we play, we will process this Spline pound. Go to world setting and change this game mode to vehicle game mode. And we can close this vehicle game mode. Go to event graph. Event process. We can delete this event. We only need event begin play. Get controller. Has to player controller. And connect to this. Get enhance input local player subsystem. Is valid. Add mapping context. And this mapping context we use IMC default. Then get player controller or set show mouse cursor and set to true. Get actor of class. BP vehicle AI. Promote to variable. And name this variable is vehicle AI. IA look. Enhance input action. IA look. Get player controller. Show mouse cursor. Get show mouse cursor. If this false, add controller your input. And this is this action value. We can split this like X to this your input, and another one is pitch. Add controller pitch input to this Y. We can comment on this. C camera input. Play this. We still can move around. Right mouse button. Get player controller that show mouse cursor. And when this fall, set it to fall when we press, and set to true when we release. And left mouse button. The same. When we press it fall, and when we release it true. So when our mouse press, we can look around this because this show mouse cursor is fall. And if we release, we can look around. Let's play. Hold right mouse. Now we can look around the scene. Back to BP fly pound. IA move. And we can split this action value. Copy this. Get control rotation. Get forward vector. Multiply. Change this to float. And we call multiply. Make this y multiply with 50. And another one is right vector. Multiply with 50. Convert this to float. X value. Then add this together. Get actor location. Add or set actor location. This new location and set when it's fall. We can comment on this by pressing movement input. When we play, hold right mouse and press WASD, we can move around the scene. But we want Q and E to able to fly upward and downward. Go to BP fly pound and we can search for MC default and this action. Duplicate this IA jump. Rename this to IA up and duplicate IA down. Open IA down. This trigger we delete this. The same as this one, we delete press and release. Go to input, IMC default, add mappings, IA down, and add another one is IA up. And we can choose this key. Down is Q and another up is E. And these triggers we add press and release. The same as this up, press, release. And we can save and close all of these. IA down. Copy this. So mouse cursor. When we trigger and ongoing, get actor location. Add then we make vector x0, y0 and z is minus 50. Set actor location. Need to new location. And when it's false, IA up. IA up. Copy this. Ongoing. And we copy that actor location. When this false, z is 50. And play this. Now we can use E to move up and Q to move down and WASD, and we can look around. Go to traffic, BP vehicle AI, and create another custom event. Name is go to target location. Add input. Input name is target location. And variable type is vector. We print this, print string. First, to identify the floor, we can click on this floor and go to detail, search for text. In this actor, we add another text. Name is floor. BP fly pound. And call left mouse button. Add variable. This variable is invalid position. If the line trace is pointing at the obstacle, we don't want this position as the target location. So set this to invalid first. Call multi line trace for object. Get player controller. Convert mouse location over space. Because we want this line trace start from the mouse location. And this start add with this verb direction by multiply this with this to float 30,000 and connect to add. Make object type verb static and verb dynamic. Then we create the branch. This hit array call for each loop when this true. Then break hit result. For this hit actor, get text. Check if this actor is our floor. So get the first array of this text equal to floor. Create a branch. If this true, we set hit location. Another variable, hit location. Vector. This location as hit location. And if it falls, we set invalid position is true. When we complete this loop, we get invalid position, create a branch. If this false, we call AI, call go to target location, and get this hit location, connect to target location. And let's play. Now we can press on this. We forget to draw debug type for duration. But we have this error attempted to access index row from array text of length 0. This caused by this one. We should use this get a copy. And play again. Now we don't have any error when we stop playing. Go to BP vehicle AI. We want to create the new spline from vehicle location to the target location. So we need the path to the final target. Add function. Function name is add path location to target. And this input is vehicle target location. And the local variable actor location. Variable type is vector. Another one is previous location. Break this location. Make vector. And connect Z to Z. Get actor location. Break vector. X to X, Y to Y. Set actor location. And set previous location. Add variable. The variable name is add to final target. And change this to array. Clear this. Add. Get path to final target. Add actor location. The first point is actor location. And get previous location. Distance. Add another variable. Name is final target location. Change this to single. And this event, we can delete this print string. We set target location to final target location. Get final target location. Character. Get grid gap. And to float next to this character. And call while loop. If this distance from previous location to final target location greater than grid gap, we continue this loop. And if it falls, we complete. Next, we get actor location, get unit direction, final target location, multiply this with grid gap, to float, convert this to float, add, we add with previous location, get path to final target, and add the array and this loop body. Then we set this location to previous location. So we add the position with this distance of the grid gap to this array. And then we use this as the previous location, add with this direction again and again until we arrive at this final target location. And when we complete, we get this previous location, distance with final target location, greater this grid gap divided by 3. And when this complete, add final target location. We add this because we have some space, so we need to add another final target location at the end and return. If it's true and if it false. Next we go to search for spawn new spline. We need to make some adjustment. When this complete, we set this avoid obstacle and this stop and wait, we disconnect this or return. Add output. Name this new spline actor. Variable type BP spline row. Object reference local spline actor. Connect to this. To event graph. And we find this spawn new spline. Let's set this to spline actor. Then call set spline points move data. And we can go to this found new spline. We can delete this. And we can copy this. Stop and wait, delete. And pass this here. But we don't need to connect to this stop and wait. We need the different logic for this. Let's call this reset, analyze, and map. Add variable. Arrive at final target. And boolean. Set this to false. Then we call add path location to target. And this final target location is our vehicle target location. Get default spline. Is valid. And if this valid, we destroy the actor. Destroy this spline. Or spawn new spline. Next, it's not valid to this spawn new spline. For this spawn new spline, we need to add another input. This input is spline points. Change to vector and array. Then we get these spline points. Need to for each loop. And these spline points set to offset tangent location. Go to event graph. We get path to final target. Connect to these spline points. And for this spawn new spline, we connect this path location to these spline points. For this output, we set to default spline. And then we call reset default spline. Open this reset default spline. And for this spline actor, we call is valid this function. or AND Boolean and connect to this branch. Compile and save. Let's play. Now when we click at this location, the vehicle will use this location as the default spline, and it spawn another location to avoid the obstacle. We need to check if the vehicle is arrived at the target location. We need to stop the vehicle. To BP vehicle AI, add macros. Name this is final target arrival. Add input. Change to execution pin and execute. And this output. Then set arrive at final target to false. Get default spline. Call is valid. Then get spline. Is closed loop. If it falls, it means that we move to target location. Create branch. And if it is closed loop, we connect to this output. And if it falls, we create a sequence. Get actor location, distance, actor location to final target location. Less than grid gap. To float, multiply by 1. Create a branch. If this true, it means that we arrive at final target. Set this to true and set forward true. If this false, we not yet arrive. Set this to false. Get final target location. Draw debug sphere. The radius is 30 and red color. Duration 0 and the thickness is 2. We set duration 0 because we will call this function every tick. Then get arrive at final target. Create a branch. If this true, we call stop vehicle. And if this false, we connect to output. To event graph. And before this, we can delete this player process We will create another mode for this player process. But now we don't need this. Delete player process variable. You can find class member and disconnect this player process and delete this. And this player process variable delete. All final target arrival macro connect to this. And we have this stop vehicle. We need to set this throttle to 1. And before this, we get vehicle movement component, set handbrake input, set this to true. And save. And play test. We set this target. Let's see if this vehicle stop at the target. Now the vehicle stop when it arrives at this target location. Create enum to store different vehicle mode. Enumeration E vehicle mode. Then add enumerator follow line loop. Move to target. Follow player. And player process. And save. This BP vehicle AI. Let's add another variable is vehicle mode. And set this to vehicle mode enum. All this overlap, we can create another category is overlap. Overlap back to overlap category, overlap right, overlap left. Go to event graph and create another custom event. Name this to update target location. Get vehicle mode push equal enum. If this equal to spline loop, we don't update the target location. If this false, we set this arrive at final target to false. Go to BP fly pound and because we get vehicle AI Set beacon mode. Set this to move to target, because when we set the hit target location, we need to change this beacon mode to move to target. Go to, we forget to compile, so we get this error. Let's compile again. And final target arrival is okay. Check target arrival. We need another Boolean to check that if the target arrival of the spline that avoid the obstacle is near that final target location. If it is near, we don't need to spawn another spline. Get spline actor. Get spline. Get location. Add spline point. And coordinate space is world. Get number of spline points. Next to this point index. Get final target location. Distance. Greater. Grid gap. To float. Divide by 2. Next to this, we can move it up here. Then call select. Deselect. When this fall, get default spline. Get spline. Is closed loop. And if this true, we set this to true. And if it fall, we use this. And next to end boolean, next to condition. And after this, we call update target location. Go to event graph. Perform k-turn. After we complete the perform k-turn, we call update target location. We can use this condition. Lab as function is final target near spline last spline point. Set this to pure. and we call this is final target near last spline point. We can copy this and connect only this. And we check this here. When this fall, and perform k-turn. After this, we create a branch. If this fall, we update target location. If it's true, we don't update the target location. Close all of this. Add another function. Reset spline on distance. Line trace by channel. Get actor location from start to get offset target tangent location. And we call all boolean, create a branch. Get actor location, distance from this offset tangent location. Greater or equal grid gap to float multiplied by 2. Or and boolean get forward. And overlap front, get overlap right or overlap left. Or and connect to this end. Or and another condition is greater than 3 and connect to all. If this condition is true, we reset. Get we call mode for to move to target. Create a branch. If this true, we update target location. If it false, we reset default spline, reset, analyze and map, and analyze and map obstacle next to this. We use it after we call this calculate steering input because we have this offset tangent location in this function. For reset spline on distance, compile, and let's play test. You can see this location, this spline is point to the wrong location. We need to improve the base target location. We need to improve this find base target location. This score, get default spline, get spline, is closed loop, create a branch, if this false we set score, get grid location, and find the distance from grid location to final target location. We want the base score is the score that is near the final target location. And we copy this. Get start location. Subtract this distance. Get score. Subtract this. And set to score. And save. Now let's play test. And we click on here. We can see this avoid obstacle spline. It leads this vehicle to this final target location. We want this target location to adjust it away from this obstacle because it is too near this obstacle and the vehicle can reach this location. The tool BP we call AI. Go to refine path with obstacle avoidance. This adjust path away from obstacle. For this normal, we need to change this. Make rotation from X. Click. Then make rotator. Then yaw to yaw. Get rotation X vector and connect to this vector. Because we don't want this normal vector to have this roll or pitch rotation, we need only the yaw. To event graph and add another function. Adjust final target location. Add this input is target location and change this to vector. Create a sequence. I spell this final wrong. Final. And then add local variable is target vector. Set this target location to target and call adjust path away from obstacle. Get grid gap to float multiply by 2. This is the speed radius. Get target and make array. Make this array to original path. And this adjusted path we get a copy row index because we have only one array element. Then we set to final target location. Go to event graph. So we don't set this directly, we need to adjust this first. Adjust final target location. This name we have a lot of space. Then clear this space. And connect this target location to the target location. Let's play. Now when we click near this obstacle, the normal of this target location will push to this location. Search for max speed and change this max speed to 20. Go to our project location. I want to adjust the algorithm a little bit. Let's go to traffic tutorial. Go to plugin, algorithm, source, public, private, algorithm BP library, algorithm BP library.cpp. You can close this my spline component. Go to algorithm BP library.h. Wait a little bit until this background text is ready. From the last tutorial, I used this get vehicle neighbors function. For this function, we get the neighbor that is forward vector, forward minus 45 degree, and backward of the vehicle to make sure that the spline is smooth for the vehicle to turn. But now we have this refined path with obstacle avoidance. So we adjust the path away from the obstacle and smoothen the spline. So we always get the smooth spline without this get vehicle neighbors function. And this get vehicle neighbors function can cause the A-star algorithm cannot find the path to the target location, even if it is available if we get the neighbor in the default function. So we can delete this. Rotation vector, delete this get vehicle neighbors and save. Go to this algorithm, cpp, delete this function. These vehicle neighbors and get neighbors. We don't need this forward vector and delete all of this. And save. We can close this and close this Unreal Engine project. Next, we clean this project, delete binary, derive data cache, intermediate, save, .vsconfig.sln, and this plugin we delete intermediate. Right click and generate Visual Studio project. Open this graphic tutorial.sln. Then we run this. We can open this project. Go to BP Vehicle AI. Close all of this function. We want to adjust the spline to the floor level. So add another function is get vehicle floor height. Add input actor and this actor name is vehicle actor. Get actor location Add this. Height is Z200 and another Z is minus 1000. Call line trace for object. Is start and add. Make object type burst static. Then break this location. Break. Return. Return this Z value. And rename this to Z value. We do the line trace downward. So when we overlap, it is the Z value of the floor. And set this to pure function. To event graph, we can connect this and don't need this sequence. Copy this and delete. Go to initialize. As it here. Create sequence. And this Spline actor. Set it after this default spline. Get shape. Call get we call floor height. And connect this shape to we call actor. Add another variable is floor height. And change this to float. Move it to obstacle. Set this floor height. Then we adjust this adjusted path. Add another local variable is adjust points. Vector and array. Adjust points. Clear. For this return, we not yet return. Call for each loop. Then break this vector. Make vector x to x, y to y, and z is our floor height. Adjust points. Add to this array. After we complete, we return this adjust points. as suggested path. Compile and save. Play. And here you can see this line is on the floor. Go to BP fly pound. This draw debug set to none. Next, we want to set this stop and wait. Add another function. Name is spline too short. When the spline is too short, we stop the vehicle. Get spline actor. Get spline. Get spline length from the spline actor. Or less. Get final target location. Distance. From this spline actor, we get spline. And get number of spline points. Get location of spline point and use this number of spline points as the point index. Set to world coordinate space. Find the distance from this final target location to this location. Check if it's greater. Get grid gap. To float. Multiply with 2 into this float. And call select. This when it fall and say true. Get default spline. Get spline. Get close loop next to this. Call n boolean. Then call return to this return. Go to event graph and for this stop and wait. After we spawn the spline to avoid the obstacle, we check that is spline too short. Set this to pure function. Set this. We can move this vehicle backward and duplicate this. set to 100. Play. And we set the location. Now when the spline is too short, the vehicle will stop and wait for the better target location. We can delete this. Go to BP vehicle AI, add another function, can reach grid edge, add input, reachable points. This is point array. For each loop, we break this point, and if h is equal to 0 or equal to grid width, subtract with 1 next to this to all. X equal to 0, y equal grid height, subtract with 1. All. Create a branch. If this true, we return add output boolean reachable and to single. Set this to true. And it's complete. We set this to false, reachable. Go to event graph. After we do the plot wheel, we all can reach grid edge next to these reachable points and create the branch. If this true, we continue, and if it false, we set stop and wait to true. We do this because when the vehicle stay inside the obstacle, example, we duplicate this and move it back, and it's trapped inside this. When we play, the vehicle will stop. And if we delete this, vehicle have the spline to move, so the vehicle will follow this spline, get out of this obstacle. So we can delete this. That's why we use this function. to check that if the grid edge is available. Another improvement is this line trace obstacle. If this line actor is not valid, we don't need to check this. And delete this stop. This one is done. Now we have multi-target system. Let's set this target to this location. And it's working. Now we want our vehicle AI to follow player vehicle. Add another variable is player vehicle single BP vehicle object reference. Go to this initialize vehicle variable. We can delete this process. Then add input. Name is vehicle mode. Vehicle mode enum. Then call switch to event graph and set this vehicle mode. If the vehicle mode is follow spline loop, we get the nearest spline and then set it to default spline. Add another function. Initialize move to target. Call get all actor of class. BP line route we call for each loop. Then destroy all the spline. When we complete stop vehicle, get actor of class, BP fly out, get player controller, process with this BP fly pound. And we get this player controller that show mouse cursor. Set it to true. go to initialize vehicle variable, then call this new function initialize move to target. Like this move to target, and we can copy this, destroy spline, follow player, get actor of class. We want to process this police vehicle, BP vehicle 13 car, BP vehicle 13 car is valid. If it's valid, we set to player vehicle. And then we get player controller called process. Process this player vehicle. Set show mouse cursor to false and call update target location. And if it is not valid, set vehicle mode to move to target and call initialize move to target. Let's set this vehicle mode to this follow player. Let's go to event graph. This update target location. We get vehicle mode equal enum follow player. Create a branch. If this true, go to target location and use this final target location. If this false, we call this arrive at final target, and this adjust final target location. We need to change this target when we follow the player, so this target is the player location. So add input, vehicle mode, get this vehicle mode, and we check this for enum follow player. Create a branch. If it false, we set this target location as the target, and if it true, get player vehicle, get actor location, break this vector, make vector x to x, y to y, get vehicle, player vehicle, get vehicle floor, height, connect to z. Then connect this to target. Go to initialize vehicle variable. We need to check that if this nearest spline is valid. If this not valid, we set to move to target and initialize move to target. Get actor of class BP fly pound. We call get player controller process this. Copy player controller. Set show mouse cursor. Set this to true because we can choose the target location if we want when we show mouse cursor. We can close this function. Go to final target arrival. And we want to check this. Get vehicle mode equal enum follow player. Create a branch. Get player vehicle. Get actor location. Get final target location. Distance. Greater than. Get grid gap. To float. Multiply by 6. And create a branch. We check this because we want to update target location. We check this because we want to update the target location when the vehicle move. And connect to this branch. When it's false, we continue. And this one false, we continue. Can comment on this. Update target location. For player vehicle. Go to final target arrival. And this arrival distance, we can change this. Vehicle mode equal follow player. Select float. If this true, set to 3, and when it's false, set to 1. Now we can change this to 4. We don't want AI vehicle to hit our player vehicle. Go to event graph, and this adjust path away from obstacle. We need to check the actor, this hit actor. If it's not equal to get player vehicle, need to this, call is valid. And create a branch. If it is true, we set to this normal. We do this because we want the final target location. It adjusts away from the obstacle, not from the player vehicle. Make sure this vehicle mode is follow player. And let's play. Now we possess this police vehicle, and the vehicle AI will follow this police vehicle. You can see it moved to this location of the vehicle, and after it arrived, it stopped the vehicle. The two vehicle AI. This initialize vehicle variable. Another mode is player possess. So we want the player to control the AI vehicle. First, we destroy the spline road. Get player controller possess. And this count is safe. Get player controller or set show mouse cursor. Set this to false. To event graph. For this spline, we want to change the color of this spline. The default spline is white color, and this avoid obstacle spline is blue color or green. get spline, set and selected line segment color. Make this color. Green is 1, blue is 0.5. And we change this vehicle mode to player process. And let's play. Now we control this AI vehicle. We can drive this vehicle. Next, we want to switch between different vehicle modes. Open the wall blueprint. Get actor of class. VP Vehicle AI. Promote this to variable. Variable name is Vehicle AI. Get Vehicle AI. Get Vehicle mode. And print string this vehicle mode. Tab key. Keyboard event. Get vehicle AI. Call is valid. Then get vehicle mode. Find the next vehicle mode by add it with 1. Get number of entries in a vehicle mode greater or equal to number of entries in a vehicle mode. Create a branch. If it is valid, and we check if it greater or equal to this number of the enum, we reset the enum to the first one. Get vehicle AI. Set vehicle mode to follow spline loop. Copy this. Set vehicle mode. With this next vehicle mode. If it falls, get vehicle AI. Call initialize vehicle variable. And copy this vehicle AI. Get vehicle mode. And set to this. Call print string. Compile. Go to BP vehicle AI. Initialize vehicle variable. Then we set player vehicle to empty when we initialize. Get player controller. player index 0 and process. And then we spawn default controller. We unprocess this first, and then we do the process with different enum. Add another variable is previous vehicle mode. Change enum to vehicle mode. Get previous vehicle mode equal to move to target. Create a branch. If this true, we set controller rotation. Add another variable, controller rotation. Rotator, and set this rotation. Get player character. Get control rotation. To this. And copy this. For this initialize move to target, we set to this controller rotation. Go to city sample vehicle. At vehicle AI, set previous vehicle mode. And set to this. Use this vehicle mode as the previous vehicle mode. Next, in this begin play, and go to this controller rotation, copy, and set this rotation to begin play. Search for another function, find next spline location, and this spline actor, check if it is valid. Is valid. For this begin play, get player controller, set control rotation, and find the variable controller rotation to this new rotation. For all these variables, we can create a category. The category is move to target. And set to this move to target category. This max speed. For moving forward, we multiply this with 1.5. The two event graph. This set control rotation, copy this. The two initialize and initialize move to target. We set this control rotation. We don't need to set this variable again. And now we can close all of these functions. Compile and let's save all. Go to this vehicle mode and set this to public. Change to follow spline loop. Let's play. We have an error access none trying to read property from get player character. In begin play, sorry for this mistake, we need to get player controller and get control rotation next to this controller rotation. We can disable this debug. Search for debug, or we can go to debug control. This debug pattern, disable this, set it to false, and save all. You can duplicate this and create different kind of obstacle. And because I already have the scene that I already created, I can delete this code and I copy from that scene and pass it here. And change this vehicle mode to move to target. We have an error access none try to read property. This rotation we get player character. We need to get player controller instead. Get control rotation and set to this. Let's play test. We can set this target location. We can change the target location anytime. We don't need this vehicle to arrive at this target location first. Example, if you want to change to this location, this vehicle will calculate the different path to this location. And press tab to change mode for the vehicle. And now the vehicle can follow player vehicle. If we get out of this, press F8 to see this. You can see this vehicle try to arrive at this location. Press tab again. Now we process the AI vehicle. Press tab again. We move to target. This is the end of our tutorial. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.